What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 6.5 scientific notation. So let's go ahead and get started. Scientific notation is a way to write really large and really small numbers. So for example, when we have a super small decimal with tons of zeros or a large number with tons of zeros, these are easier ways to write them. And we're just going to figure out where can I put the decimal and what should it look like. The first thing I want to know is how to know if something is in scientific notation. In order to know if something is in scientific notation, we're going to have a times 10 to the n, where a has to be greater than or equal to 1, but still less than 10. And then n just has to be an integer. We usually pick positive and negative or with whole numbers. Okay, so the first one, 5.9 times 10 to the negative 6. 5.9 is bigger than or equal to 1, but still less than 10, so that checks out. And negative 6 is an integer, so that also works. So we can say yes. This next one right here, 0.9 is not bigger than 1, so we automatically have to say no. For the next one, 2.5 is greater than or equal to 1, and my exponent is an integer, so I can say yes. And then the last one, I'm going to have to say no because 51.2 is still bigger than 10, so we're going to say no right away. Okay. When we convert to standard form from scientific notation, negative exponents means we're moving our decimal to the left that many times. Positive exponents means we're going to move our decimal to the right. So let's go ahead and try some questions. You may already remember this from a few years ago when you first saw it. What you do is you first start by writing your number, and then you take your exponent to whatever 10 to the whatever power. That's negative 4, so that means I need to go 4 spaces to the left. So I'm going to count 1 scoop, 2 scoops, 3 scoops, 4 scoops. Notice how I had to scoop over the 3. Empty spaces I fill with 0, so I get 0.000322. With this one, I have a positive number, so this means I'm going to go to the right that many times. So again, start by writing your number given to you and the first part of that, 7.9, and then I'm going to scoop 5 times to the right. 1, 2, 3, 4, 5. Fill up with any empty zeros, so I have 790,000. How about you pause the video and try these, and when you're done, click play to check your work. So 2.75 times 10 to the negative third means I take 2.75 and move it over 1, 2, 3 to the left. Fill up with empty zeros, I get 0.00275. If you want to add an extra zero in front, you can. I'm not really picky about that, but that is an option too. And then 6.38 times 10 to the 7th, that's 6.38, and then I scoop over 7 times to the right. 1, 2, 3, 4, 5, 6, 7. Fill up my empty spaces with zeros and rewrite without the hoops. 638 with 1, 2, 3, 4, 5 zeros. So this number is 63,800,000. Okay. Again, some extra examples. This one does not have a decimal, but 6 has an imaginary decimal behind it. And when I move it over 7 times to the right, I'm going to fill each one of those empty spaces with a 0. So this will actually give me 6 with 7 zeros, or 60 million. 1.285 is a long decimal, and that's okay because it's still equal to or greater than 1, but still less than 10. And I move it over 1, 2, 3, 4 spaces to the right. I'm left with 12,850. Okay. An object with a lesser density than water will float. An object with a greater density than water will sink. Use each given density to explain what happens when you place a brick and an apple in water. So less density within water. So first what I want to do is go ahead and write out water in standard form. That is 1.0 times 10 to the third. So 1, 2, 3, or 1,000 density. A brick has 1.84 times 10 to the third, so that is 1,840. So this looks like it'll sink because it's a greater density and it will sink. An apple has 6.41 times 10 to the second, so that's 641 density. This one is lesser density than water, so this will float. Okay? A flea consumes about 1.4 times 10 to the negative fifth liters of blood per day, and a dog has 100 fleas. So how much blood do the fleas consume per day? Well, the first thing we want to do is figure out what is 1.4 times 10 to the negative fifth. It's 1, 2, 3, 4, 5 to the left. So 0.00014. That's per flea, but he has 100 fleas. So we're going to multiply that by 100. So we can type that into our calculator. 0.0000, so 4 zeros, and then 14 times 100. 1, 2, 3, 4, 4 times 100. We're going to get 0.0014, and if we put that back in scientific notation, we'll have 1.4 times 10 to the negative third. Okay? What if the dog has 1,000 fleas? How much blood is consumed per day? So now we just again take that 0.00014 and multiply by 1,000, and we're going to get 0.014, or 1.4 times 10 to the negative 2 power. Okay? Now we're going to talk about converting to scientific notation. The first thing we want to do is move our decimal so it's to the right of the first non-zero digit, a 1, a 2, a 3, 4, 5, 6, 7, 8, or 9. Count the number of places you move the decimal. If the number is greater than or equal to 10, we're going to use positive exponents, but if our number is really small, between 0 and 1, we'll use negative exponents. So let's try it. First thing I'm going to do is find out where I should place my decimal. I want it to be here in between the 1 and the 6 because it's going to make the decimal 1.65. Greater than or equal to 1, but still less than 10 is what we're shooting for. Times 10 to the what power? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right, so that'll be 10 to the 9th power. The next one, I'm going to place my decimal between the 2 and the 6 to create 2.68 times 10 to the 1, 2, 3, 4, 5, 6 power. This is going to be a negative 6 because I had to move back to the left to create my small decimal. 50,000, that'll be 5.0 or just 5 times 1, 2, 3, 4, 10 to the 4th positive power. 25 million will be 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Positive number as well. And then last one on the screen, we have 4.5 as my decimal, times 10 to the 1, 2, 3, 4, 5, 6 power, but that should be a negative 6. Okay? Again, let's practice with some of these. Maybe you pause the video here, try this one on your own, and when you're ready to click play. So 6.83 should be our decimal, and we only had to move this decimal twice to the right, so that is 10 to the second. 0.005, my decimal needs to be after the 5 to create 5 or 5.0, and 1, 2, 3 back to the left, so that's 10 to the negative third. The one we have here, decimal should be 3.3, count it back, 1, 2, 3, 4, 5, 6, 7, so 10 to the negative 7th power. And then my decimal needed for the next one, 5.06 times 1, 2, 3, 4, 10 to the negative 4th. And then our last one, 2.45 is where my decimal needs to be. Count it back, 1, 2, 3, 4, 5, 6, so 10 to the positive 6 power. Okay? The last one talks about comparing and ordering. So the table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. So earliest would be a long, long time ago, and most recent is going to be not as long. Okay? So what I would do is I would write these out in standard form. So 5.42 in standard form would be 1, 2, 3, 4, 5, 6, 7, 8,000 years ago, or 542 million years ago. 6.55, 1, 2, 3, 4, 5, 6, 7, or 65 million years ago. That one's looking like a long time ago, but Paleozoic seems really, really long. And then 2.51, 1, 2, 3, 4, 5, 6, 7, 8, or 251 million years ago. So this would be earliest, number 1, then Mesozoic, and then Cenozoic. Okay, T-Rex lived 7.0 times 10 to the 7th, so it's 7, 1, 2, 3, 4, 5, 6, 7, or 70 million years ago. During which era did he live? We would say it is closest to the Cenozoic. Okay, ordering numbers from least to greatest, again, we would just write these in standard form. So 6.8 times 10 to the 4th, that's moving our decimal 1, 2, 3, 4. So 68,000, 2.04, 1, 2, 3, 4, 5, 204,000, and then 5.65, 1, 2, 3, 4. So we have 56,000 first, then 68,000, then 204. So that would be our order, 1, 2, and then 3. Okay, that'll conclude our video on scientific notation. Thanks for hanging in there, and hopefully this video helped you. If it did, give it a thumbs up, and we will see you next time. Have a great day.